questions for Luke or for Joseph?
I'm sure there's a lot of people in this room who would have owned houses and would have dealt with what they perceive to be energy problems in a form that you're saying is probably inefficient.
Yeah.
And where thermal bridging hasn't been taken into account.
Yes.
Now, you dealt with obviously what we should be doing. You can't rip out that stuff and do it again. It's just there already. It's there already. What do you recommend for situations where, you know, a person has been told insulate the attic, change the windows, internal or external insulation, but thermal bridging hasn't been taken into account obviously because you know it's blatantly obvious. And you can't nobody's aware. What do you do if you've done that?
I'll give you one example that I came across recently, which I'm looking at doing for my own house if the budget doesn't stretch to external insulation for the whole thing. I moved into a house that was already internally insulated with the basic, I think 50 mil insulated plasterboard, nothing special. And there was some insulation put down for the underfloor heating, but not enough by my standards. And at the junction of those two walls, you know, obviously big thermal bridge, nothing done. And you can feel it even walking barefoot on the tiled floor during the winter. I mean, the temperature difference as you walk towards the edge of the wall of the floor is really obvious. External insulation at plinth level, even if it's plinth level only, and in one case I was talking to Ballyfermot, I was talking to Dublin City Council about Ballyfermot Library. They have a problem. They've got a huge concrete slab, totally insulated. They've got cavity walls which they thought they could blow into. I've actually since proven to them they can't. They shouldn't. They're too narrow, and the quality of the building is too poor. It would be actually risky to do that, unfortunately. But what I was hoping to be able to advise them was that if they did fill the cavity, and they're concerned about vandalism as well, that they could lift the paving slabs that were in the building, and when there's lawn or grass, they could dig that up and externally insulate the plinth, so down to the footing, and stop. Okay, it's a compromise, but stop just under the paving slab. So our friend, the boyo at midnight who wants to kind of do some damage, can't see that there's any insulation. He can't see anything, but we've actually warmed up the entire floor slab. We've actually reduced heat loss through, I mean, the floor wall junction, heat loss is to the outside in that pattern, and we've actually cut that down. So even though we've a compromise and we've a thermal bridge at that junction, and it's not everything we like to do, it's certainly a way of warming up a slab. And slabs are particularly difficult because who of us are going to rip up? It's rare that you rip up the old slab if it's a solid slab, and that could also work for internal insulation. So in a domestic house, you could be bringing the insulation up, and it could architecturally be designed as a plinth, like as a visible plinth, but in that other condition it could still have a value. Now, you know, this is where thermal bridging, you can start playing with things. Okay, if I do 10 mil, if I do 20 mil, if I move this, whatever. So that could be a measure that I think an awful lot of people should start considering. Plinth external insulation.
What about, you know, wall to ceiling? You know, plinth is one thing, obviously.
Yeah.
I mean, you've got this insulation.
Well, maybe coatings, you know?
Yeah.
Maybe insulated coatings could make it come out. I'm sure that it's possible to do a mindless.
So I mean, that seems a practical solution. I mean, if you are going to lose heat, well, most people wouldn't be that concerned about losing heat. It's the moisture.
But you want the most uniform. You want the most uniform surface temperature across the building. I mean, if you have an infrared thermometer laser, you know, you can also use your hand. It's very instructive. I mean, your hand can actually be extremely sensitive. It's very instructive to follow where are the temperature gradients, what's going on, you know. I mean, for one thing, if you have a building that you're concerned about, I'm working with some airtight and thermal bridge assessors who do the same thing together. One guy who does both creates a report, €450, where that can be afforded, and you're getting an insight into every gap, every lack of air tightness in the building, and every area that insulation was missing. I was in a house recently, having asked to retrofit up in Balbriggan, and when we got the thermography done from the inside, that can be done even in summer, whereas thermography from the outside needs to be done in winter. We were able to spot about a metre of insulation missing, well, maybe half a metre of the insulation missing at the top of the cavity wall. So inside the cavity where we can't get to, we now know there is a problem in most of the rooms of that house. Now, is that because it was mineral insulation that slumped? Was it because clever Charlie, the builder, wanted to get a pint, and Friday evening never bothered to do that last lift of insulation? We don't know. But the client didn't know that before. Now they do. So that will actually influence their design and their budget decisions.
Just a quick question for Luke. Luke, did you guys track the hours that went into modelling and simulating the building?
We didn't actually, but I think I would estimate probably overall modelling and simulation would have taken approximately 1 week full-time. Now obviously it wasn't all done in one particular week. Commitments didn't allow for one person to sit down and do it all 40 hours in that week. It was done over a period of time as the paper was developed.
So it wouldn't be significant then in terms of the payback?
No.
Luke, did you carried out the work to the building that you looked at?
Certain amount of work.
Yeah, certain amount, and I don't know, I'm not sure how long ago that was, but have you got figures now to see how that has worked against the simulations that you carried out, how accurate the simulations were?
But I personally haven't known.
Like you said, there was management systems put in place, so you must be able to measure your savings.
Yes. No, I haven't returned on that particular aspect of it, mainly because of other commitments and things like that. We should have, you're quite correct. I mean, it would have been something that to look at the current situation and what we had proposed in our paper. Unfortunately, time hasn't allowed me to do it. I can't speak for my colleagues, but and I don't believe they have.
Yeah, I just sensed that the film was unfinished when you did your presentation, and I was waiting for the figures of what it actually was, so to see where it went.
Well, no, we haven't gone down that road. As I say, time hasn't allowed us to progress at that level.
What was the estimated cost of the wood?
I beg your pardon?
Did you estimate the cost of
We
the
did.
wood?
As I said earlier, I mean, there's an awful lot of figures involved in this paper that I can't show, mainly because it would take up too much time and most people would probably fall asleep looking at the figures. But all of the calculations, whether it be in relation to energy or whether it be in relation to the financial aspect of it, are all in the paper to show how we arrived at the figures that I showed to you. As I say, I couldn't include them in the presentation today.
And is that available from Cork University's website, or
It's
could you email it to people?
Yeah, sure, could do that. I mean, the paper is a published paper, and it is available through Elsevier and various other scientific journal papers and things like that. So it is available. If you want, I can.
You pass
email
on media, we
yeah,
can make available on the
Yeah,
website.
sure.
Presumably it's approximately the savings times the payback, which would be 14 times 266.
Yes.
Thereabouts.
Both of you have kind of concentrated on efficiency in sort of the way buildings are used, their energy consumption. Are there any kind of initiatives to look at the possibility of reducing demand, and that is by, for example, looking at changing people's expectations in terms of, for example, lighting level, ambient lighting levels in buildings, or ambient temperatures in buildings.
It's a really complex one. I think generally the attitude of bureaucrats and politicians is that solve the technical issues and as little as possible never ask people to change what they're doing. That's difficult. Asking people to change, get someone to give up smoking, or get someone to stop overeating, or lots of different things. They're very obvious examples. Get somebody. I work because there's an architect in the office behind my office. The amount of times I go in, and I probably shouldn't, and turn off all his lights after he's left an hour ago. He's amazing, and he's a very good guy, and he's very focused on energy efficiency. Probably shouldn't do that, but I'm on the way to the kitchen. Getting people to change in their habits is probably the hardest thing possible.
It's like plastic bags, so it's like
yeah, well, there's a stick there.
Weightage to ground in.
If you don't reuse your plastic bag, we're going to charge you.
Yeah.
That focuses people.
Well, that's how people get focused.
Yeah, people are complaining about water rates, but I think we're the only country in Western Europe that don't have water rates. That will focus people. I often give clients an energy meter, like an OWL or an effigy unit that they can attach to the meter in their house, just so they can see the energy use, electrical energy use in their house, simply by seeing a figure. I think this is what you were saying earlier on. Simply by seeing a figure, it actually changes your mentality. And you begin to know, for instance, what's your normal nighttime energy use, or, okay, that's higher than normal. Did I leave the light on in the attic? I mean, you can take the same thing and look at an entire corporation. Just name something and measure it.
Just looking at some of the diagrams that you showed where there's kind of heat loss across the wall, for example, and there's assumed temperature on the inside and assumed temperature on the outside. I mean, it would just be interesting to know how those diagrams would differ if the temperature on the inside was, say, half a degree lower or something like that.
Yeah.
And I mean, what I'm just wondering is, in the overall scheme of things, would it make sense for somebody somewhere to try and change people's, the consumers'
We have to.
consumers' sort of expectations in terms of energy consumption?
Yeah, we have to, but that's, for instance, if you look at the green schools movement, primary school kids are coming home saying, Mummy and Daddy, why aren't we recycling? Isn't that obvious? And then Mummy and Daddy start recycling. I mean, it is being done in many ways, maybe not enough ways, but I'd say that's the biggest, hardest thing, because you can give somebody a passive house building, which has 10% of the energy use of a normal regs compliant, 2007 regs compliant house, let's say, and you can still use that as a high carbon, high energy house. If you want to misuse a piece of technology, it's very easy. And one of the problems we have in terms of the other end of the market, kind of bringing people out of fuel poverty and bringing the mass housing market now to C1 or B3, is that an awful lot of people have not been heating their house, as is assumed by DEEP, let's say, to 19 or 20 degrees. They're actually surviving on 17 degrees in one room, and they wear a jumper in the other rooms. That's what they use blankets for. There's people living in really difficult conditions, and even they're not just working class, middle class people. We're in difficult times. When you insulate that building to a state where it's now easy to heat it, and it's easy to have higher thermal comfort levels, the first thing people do is a bit of a clawback, which you can't blame them for. They start living at 19 or 20 degrees. It's hard to say that that's wrong. What is wrong is living 50 miles from your workplace, or 2 holidays a year by plane, or you can talk about those things. You can talk about water usage. You can talk about lots of things. But a bit of a clawback from a proper energy efficiency retrofit of a house that was already substandard, that seems to be acceptable, because that's about social justice. So it's complex.
Just one thing I might add to that. In UCC, for example, every Monday, we get sent an email that shows us exactly how much energy has been used in the previous week, whether it be lighting or heating or whatever it is. So every week we are reminded about how we are either saving or abusing the system by looking at this graph. It also encourages people, remember to turn off your computers, turn off lights, etc., etc., etc. So when you actually leave your room on a Friday afternoon, it tends to stick in your mind, okay, just make sure the computer's turned off. It's a way of getting across to people, look, try to be more energy efficient. And subconsciously, it's always there before you leave the office at the end of the day or at the end of the week or whatever, to try and minimize the amount of energy that's going to be used when in an occupied office, if you like. So that type of thing, is used to try and encourage people.
One thing that struck me about the example that you gave is that when that building was built, the energy consumption was probably much lower.
Yes.
Because people's expectations were lower.
Exactly.
There may or may not have been electric lighting in the building.
Yes.
So it might only have been used during the daytime, for example.
Yes.
And when it was being used, people might have been satisfied to carry out their experiments or whatever they were doing with lower level of energy environment. So
Yes.
I think it's just worth having that in the back of your mind when you look at the building like that.
Absolutely.
Could you actually model if you open the window, and that's if you externally insulate and then you open the window, you could potentially model how much heat loss there is, to advise people on changing their habits, if you like.
One of the things with simulation is you can get lost in the machine. You were saying about the temperature differences. there's a standard for thermal bridging in this country is between 20, you measure so that everyone measures the same thing, 20 degrees inside and 0 degrees outside. Obviously, like U value was 1 degree difference between inside and outside. There's standards for that, but you could model infinitely, you could do anything, but you know, do you have time, will you get paid, and will that actually get lost in noise?
Also that we should have a vapor barrier, should be a vapor line in the buildings where design, not design, yes, but when, in the last example, you were saying a situation that you shouldn't have vapor barriers.
Yeah.
You know, is there guidance about that in the future? How do we know when we shouldn't be doing what we told for ages?
I know. What I'm showing you there is a bit shocking because it's contrary to what's understood to be best practice. Like I said, the unfortunate thing is we've been using, and it's a very easy example, when you use tools, and those tools are set up in a certain way, and there's certain limitations, and they have certain rules that underpin them, if you start thinking of the world through those tools as if that's a lens, and that tells you how the world works. I mean, even high-grade urban simulation excludes certain things, but the Glaser method, which has been there for 50 years, 60 years in the industry, has actually influenced the way we think in an industry. And for instance, if you and this is the answer. If you took, for instance, a 50 millimeter thick, okay, being ridiculous, a 50 millimeter thick brick wall, and put it in west facing in Clifton, and put 300 millimeters of insulation behind it, and then put a vapor barrier, okay. Now, I think most people in this room would tell you that wall will be pretty damn wet. It's 50 mil thick brick, you know, unrendered, and it's facing the sea, you know, in a very wet, rainy part of Ireland. Glaser will tell you as long as that vapor control there is there, there's no problem, it's fine. Because its rules, its world shows that the only place vapor comes from, there is no such thing as water, the only place vapor comes from is within the room. So vapor control there controls that, therefore tick, 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 everything's fine. But that's clearly ridiculous, but that's how we're designing buildings. That's the tool that we've been using. And that's why it's considered best practice to put a vapor control layer on the inside of every type of internal insulation. Now, I'm obviously a big external insulation fan, but sometimes you have to use internal. And what we're discovering here, and it shouldn't really be used for a small practice in Dublin in 2011 to be finding this out, but we are using validated software under European codes, etc. That code came out in 2007. We're finding that actually that way of thinking is entirely wrong-headed, and even a good vapor barrier, which has a small vapor resistivity, or even insulated plasterboard, which is that bit more vapor resisting, can actually slow down the drying process of the wall, and that's more important. The wall has to continue to dry out. If it doesn't, we will always have problems. So I'm telling you now something you will not hear from an information, you will not read in an information panel, you will not download from the government. It's not in the Home Energy Savings Scheme Code of Practice. It may or may not be in the retrofit code of practice created by the BER when that comes out next June, probably. I'm hoping it will be because I'll be on their door. So unfortunately, there's an awful lot out there that needs to change. There's an awful lot that's good. I mean, vapor barriers in timber frame, in a roof, all sorts of areas, it's fantastic and always should be there. But we need to reassess some of our thinking because some of it's slack thinking based on simplified, inaccurate tools. And we have reached the world of BIM and proper simulation and cheap hardware that has, you know, high processing speeds. We need to use it because that's closer to reality.
Okay, we might just leave it there then. Thank you very much. I'd like to thank both Luke and Joseph for their presentation.